Good morning, friends. In my last video, I explained you directive influence of the substance in benzene ring. You see, benzene ring, suppose it is monosubstituted by group A, then what will happen to the second substitution? Where that second separated group will go to the ortho position or meta or the para. This depends upon the group already present in the benzene ring. And in my last video I explained you there are two types of the groups. One is electron releasing and other is electron withdrawal. Electron releasing means they activate the ring, while the electron withdrawal means they deactivate the rings. Now the electron release means they increase the overall density of the benzene ring, and the electron withdrawal means they decrease the density of the electron in the ring. In my last video, I explained you by giving an example for the ortho and the para orientation. And very important thing was that in the case of the halogens, due to the negative indectic effect of the halogens, they are ortho and para positions in nature, but they deactivate the benzene ring. This all I have stated in my previous video. Now today I will explain you electron withdrawing group. These are electron withdrawing group. They are the meta directing groups and they deactivate the ring. For example, cyanide groups, nitride groups, aldehyde, carboxyl groups, etc. Now these are the groups, they have a tendency to withdraw the electrons, and we say that overall density of the electron decreases in the ring. Now if you see the resonance structure of the electron withdrawing group, suppose here if we take the example of the nitro group. Now if we see the nitrobenzene, one double bond with nitrogen oxygen and one is single bond. Now this, if withdraw the electron, what will happen? See, this double bond of the oxygen, it means this oxygen withdraw the electron and the density of the electron increase at this oxygen. And then what happens to the resonance structure? This one of the double bond will shift back to the nitrogen and the oxygen, and there is a decrease in the density at ortho position. And in second case, if you see this, again double bond shifted and the deficiency becomes at the para position. And again in third structure, deficiency is at ortho position. So we say that the overall density of the electron decreases. Here we find that the ortho and the para positions, they are having the less electron density. Now it was found that overall density of the ortho and para position is less than the meta position. From this structure you see the position of the ortho and the para, they are showing that density is very less. So in this case, only the two meta positions, they are rich in electron as compared to the ortho and the para positions, so resulting the meta substitution. So from this resonance structure, we see that the density of the electron is more or less at ortho and the para position as compared to the meta position. So these groups, they are the meta oriented group and the meta substitution takes place. If we take the example, that is cyano group, when it undergo nitration, it forms the meta position, that is meta nitro. So the effect of withdrawing the electron causes the meta orientation, that is the meta substitution. Now there are some other factors. Suppose if we take a combined effect of the inducting and the resonance, it's very important. When the two groups, they are already present in the benzene ring. So combined effect of the inductive effect and the resonance. Take an example of para-nitrotoluene. Here say two groups are there, methyl group and the nitro group. And if you see that methyl group, that is ortho-oriented and the nitro group is meta-oriented. Now see, if both the orientation, they are reinforced to each other in the direction, again listen, if both the influence, they reinforce the direction, then a single product is formed. Both the groups, here we say methyl group is ortho-oriented while the nitro group is meta-oriented. So the position is ortho and the meta having the same position. So we say when the groups, they are reinforced in the direction, then only the single product is formed. Okay. Now if the two groups are meta to each other, two groups when meta to each other, there is no further substitution is observed. There are some other methods for the substitution of such type of the compounds. So there is no substitution when two groups are meta to each other. So this is all about the directive influence of the substitution in benzene. I think it's very important to you and it is clear to you. Now if you have any inquiry, you can ask me whenever you like. Okay, I think it is clear to you. If you like my videos, please share and subscribe. Thanks very much.